Hi.
Hi, my name is Dheeraj. My co-founder's name is Lokesh. He is on the call. We are starting demo for Newton. Lokesh, we are uploading a cancer data set, which is publicly available on Kaggle as well. Uh, Lokesh, upload the data. So we have uploaded the data. How Newton works is once you prompt it, let's say you have uploaded the data. Now you prompt it to a question, right? What it will do is it will create a complete plan how it is going to solve that problem statement, write codes for it, and gives you output as a tabular output, or it could be images, or it could be insights recommendation, or it could be ML model as well. We have
Right.
uploaded the data. Show the plan first of all. The plan has been created. How it is going to verify it is first. See how it has taken the plan. First of all, it is going to verify file path and it will set up the environment to read the complete data. Then it will read the CSV file. It will show you the few data lines as well, I guess. Now go down, show the code, show the code. So it is
So it is
installing the
providing the information like Panda should be there. If it is not, then we have to install it. This is the file path, and then so the head of the data. It understood, provided the whole code to the code writer. Now code writer is going to write the whole code in one code block, and then it's going to get executed, and it gives us the information.
so
Now let's ask, like, can you explain this data set?
or first of all, let's show the top 5 rows first of all,
Yeah.
because this is not this output is not that show 5 rows and explain the columns also.
Right. Rows and all the things.
Now we have asked the question. It is going to make the plan, write the code, and execute the code.
Yeah.
Go on the planner and show the final code block.
Yeah, so it has like read the file, right? Top five is data dot head. This is right, and then data dot columns to list to get all the columns into the list. So this is what is going to happen if we look into the planner as well. This is the step by step plan. Read the file, show top five, and all the column names.
Yeah.
And as soon as we do that, it's like this. We have all the top five and the column names which are there.
All right. Let's do some ED on it.
Let's perform. Let's perform explore
ED this time. ED.
data analysis.
Yeah.
Yeah. So when we ask like exploratory data analysis, what it is going to do is like it's going to look into the data and give us some information. As of now, it is saying like we'll do some basic information, which is data.info, then to statistical summary, and then distribution of the target variable, which is diagnosis. And diagnosis is why it's a cancer data set. We want to diagnose if the information of a given patient is the patient is cancer, or if the patient has cancer or he or she doesn't. And then it's going to provide some visualizations which are going to get saved to some particular location.
Yeah.
Yeah. So it has given us some information. The index like total entries, right? And then all of these columns, how many null objects are there, non-null objects, all of this information. Then statistical summary,
Mean,
count,
median.
mean, standard
Hmm.
deviation, minimum of the same, maximum of the same,
Then
and all of
percentage
it.
values are also
Yeah.
there.
And then it gave us the information on the like target variable, benign and malignant. It just says B and M, but it understood what this B and M is, and it says like could not convert float to string. That totally understand because correlation metric should work on numerical values rather than on categorically, right? So can
Generate the
you
charts and insight.
provide some charts and insight about data? Okay, I misspelled charts, but yeah, let's see.
Chart.
Yeah.
Yeah, it's again going into the question has been provided to it. Now it will start again writing the plan and code. So,
Yeah. So now this time, if you see, the code is pretty much changed. Now previously, it went into an error as well, categorical. It solved that, convert the target variable to numeric. where is the data set, it's going to read it from there. Then it's going to create some plots on top of that, right? Distribution of the target, distribution of the key feature, correlation matrix, pair plot of selected features. And all of this is going to get provided to code writer. This one is planner, and then it goes to code writer, and then code writer is just going to assemble all the code into one place as discussed, and it's just going to execute this. Now the whole code is provided to the executor. The executor is executing this code, and we have the first chart, which is distribution of the diagnosis, which is benign and malignant cancer. And now a second chart, which gives us the distribution of the key features like radius mean. This is all regarding the cancer, texture mean, perimeter mean, area mean, and smoothness mean. And the information over here, it's this y-axis goes from 0 to 120. That totally depends on the data, like what exactly the data is. And then the x values, like where exactly the major values are there. So if we see it's left skewed, this data, and so on. And now we have another chart, which is numerical correlation chart. This is quite huge, I think so. Yeah. So that's why it's like mixed up, but yeah, that's the idea of the correlation chart.
So again, is it executing or what?
Yeah,
Of course.
maybe. Yeah. So some pair plotting SNS.
So it has taken multiple, like it is showing in this pair plot, it is showing relation between different columns and all. So
Between
that-
like diagnosis, so benign and malignant, how these are there in the, so how benign and malignant are spread over the whole data. So which data set or which data type is belonging to like benign and malignant? That is the whole, like this visualization is just trying to tell that.
all right. Let's go do some ML modeling now once it is done. Yeah.
Okay.
Can you go?
It's-
Let's see this output. Just above it.
Yeah. So the output is like
It's a basic output. Let's go.
is the basic output, and it gives you statistical summary, diagnosis, and all of it. So what we'll try to do is let's try to train an XGBoost model
To predict cancer.
to predict cancer.
And do evaluation as well, or
Yeah.
it will automatically
Evaluate. So yeah, it will take the evaluation on its own. But before that, do you want to create an HTML report out of this? Because it can do that.
take. We'll do at last. We'll do at last. The report will be created on last.
Yeah. So the question is like, let's train an XGBoost model, and this is just one of the model. You can like ask any other model to get trained, and it will take that model and train them.
But we have asked to train a specific model as of now. But if
Right.
we would have asked like what kind of models that can be created on top of it, it would have recommended all the possible scenarios and models which can be created on it.
Which
And
can,
any of the model which we have chosen at that particular time, it would have created. As of now, for the demo purposes, we are only showing XGBoost.
right,
So
right.
just created the plan. Just show the plan first of all. Explain it step by step.
So this is just the data agent. So data agent like takes care of data loading and all. But let's go to the planner. So over here, the planner is saying like to train XGBoost model to predict cancer. What we have to do is we have to do data processing. We have to do train test split.
Values, coding, and
Yeah, so that all of this like got handled in the real time. And why we want to do train test split is because we want to train the model and we have to evaluate on the model as well on the new coming data. And then it's going to train the XGBoost model, evaluate the model performance on the testing data, and then it proceeds with the execution. And yeah, we have the whole code implementation over here. And this code will get provided to code writer to write the whole code. And so it like checks the sklearn model selection to do the train test split, also taking XGB from the XGBoost library. And then it is going to get accuracy score, confusion matrix, and classification reporting and evaluation. If we want, we can have other evaluation metric as well. As we just asked, and the code got executed, the accuracy is like 95%. And the confusion matrix is also is like this, which shows true, positive, true, negatives, and all of it. Then we have the precision recall FN score. All of this in a single line of output, and then we have a macro average and weighted average of these responses.
Let's
Now, if
create
we
code. Yeah.
no, no, but if we want to do something custom over here, and if we want to ask like, can you also do maybe we want to do some ensembling, right? Ensembling modeling for better
Results.
accuracy. Yeah. So we are not asking it to to do anything, but what we are saying, like, for better accuracy, can we do ensembling model, right? And over here, the agent are going to look into the report that we have just created, right? And the model that we have selected over there, and then it is going to like create a meta model, which is a coding classifier for multiple models, and it is taking three base model: logistic regression, random forest, and XGBoost on its own, and then it is going to like create this whole model out of it, and then going to create a voting classifier on top of it to get better accuracy. So sometimes a one model cannot like do all the things, so we can have like multiple models stacked or ensembled to get better accuracy out of the data. And for that, we can have like uh, or we can ask such questions, and it is like providing one is for malignant, zero is for benign. And again, it is trained a model which is better than the last one. It got 97% accuracy this time. Yeah. Yeah. And now let's like ask it to, can you build?
No, the demo has to be only 5 minutes. Let's just
Yeah.
build HTML report, one
HTML
side conversation, one side as the code.
report for code. Can you build an HTML report and put code and sidebar input code and other information into two different spaces or parts spaces maybe. Okay, HTML report and save it with all the charts that we have generated.
Charts, code, and conversations.
Yep, let's see.
To build the report in real time, it is going to write complete HTML code where it will create the complete reports. So we'll just see how it is going to write the HTML code for that as well.
Right, right. So we are like providing support for HTML, CSS, Java, Bash as of now. And in the coming time, we'll have like more languages over here so that we can like write code in or any developer who wants to write the code in their language, like they can do that. So right now, the same thing is going to happen again. Like it's going to build a whole plan for this, and then it's going to like execute all of this, and then going to produce a report out of it, and then going to just save this report. Save it as, and like it's going to save it something like this. So let's copy this so that we can search it in the system.
Yeah, it is being executed as of now. Once the execution is complete, we'll show you the reports also.
Yeah. So this is like multi-file capability. It's just not limited to HTML. You can save any type of file. Why we want HTML? Because you can just like directly interact with HTML, and you can open it in Google Chrome, and you can see. But if you want, you can create a PDF or a Word file as well out of this, and the model is going to do the same thing for them as well.
And as of now, this whole code is running on a low-end local machine, but we can increase the output efficiency or output timing drastically if when we will post this complete code to the cloud, given that it will provided that it has GPU supports as well. So then it will run very faster. The output time is taking like 20-25 seconds to come as of now, but that will once the GPUs are there, it will be like 1 or 2 seconds.
So as of now, it says like the report is generated. Let's see if there's a report like this.
It has been generated and saved.
Yeah, it just got generated 2:10, right? We can see the timing as well. Let's open this and see what kind of report we have. So it has given the code in a separate window. It has given us the information that if you run this code, you're going to get accuracy like this, a confusion metric like this, and a classification report like this. And then it is also pasted the charts into the same report, whatever charts were there, and all the code is also here. So that's pretty much about it. That's how we think that Newton is better than any
So,
model out there.
thank you so much, Lucas, for the showing this demo. I'm stopping the recording. Thank you, guys.
Thank you.